Okay, matter notes number 4. These are due Friday, September 6th. Okay, we left off talking about mixtures, so we're going to talk about homogeneous versus heterogeneous mixtures. So all homogeneous mixtures, so these are uniform throughout. All homogeneous mixtures are solutions. And a solution exists as a mixture of two or more substances that are evenly distributed throughout the mixture. So they're uniform, you can't see any parts or chunks or anything like that within them. And the solution is made up of a solute and a solvent. The solute is a substance that dissolves. So if you were dissolving sugar in water, sugar would be the solute and water would be the solvent, which is the dissolving medium and is typically present in greater quantity. Okay, so this is a solution, which is a homogeneous mixture. Solutions can be solid, liquid, or gas. Most of the time we think of them as liquids, but it's not necessarily the case. A solution can also be a solid, which is known as an alloy. An example of this would be brass, which is a mixture of copper and zinc, bronze, which is copper and tin, or pewter, which is copper, tin, and antimony. Then you can have liquid solutions like salt water, sugar water, or water mixed with alcohol. You can also have gas solutions like air. Air is not just oxygen. There's lots of other gases that are present in the air that we breathe. What is different about a solution is that solutions do not settle. So if you were to leave sugar water, dissolved sugar water, sitting on a counter, it's not going to separate. You're not going to see the sugar eventually separate all at the bottom and the water all at the top or anything. So they stay distributed. And they don't scatter light since the solute particle is extremely small. A heterogeneous mixture can be divided up into a colloid or a suspension. A heterogeneous mixture is when two or more substances in a mixture are not evenly distributed, so you can see the different parts. A colloid has intermediate particle size. It cannot be filtered, and it scatters light, and this is known as the Tyndall effect. An example of a colloid would be something like milk. Milk has different things floating within the mixture. Fog is the same thing, blood, gelatin, mayonnaise. So you can't filter out the different parts of these things. They're what is known as a colloid. A Tyndall effect is where the solute particles reflect the light as it passes through, making it visible. A suspension has large solute particles. It does scatter light, and it can be separated by filtration. So if you think about Italian salad dressing, if you leave it sitting there, it's going to separate. So you're going to see all the seasoning, the oil, the vinegar, all the different things that's in the salad dressing. And you could separate those things out. Whereas with other things like milk, you can't separate all the different parts that's in the milk. There are different ways to separate mixtures, and we mentioned this briefly in the other Wednesdays or Thursdays notes. Filtration is one of them. So you can see a chemistry set up here. They are pouring this liquid into a some kind of paper that's filtering it, and then what you get out, you're separating the particles. So there's going to be some particles left in the filter in this part, and then the cleaner mixture, I guess the filtered mixture, is going to be left at the bottom. Distillation is when you're using the boiling point. So you've got this flask here has two different liquids in it, which has two different boiling points. Okay, so you're going to use, this is a Bunsen burner down here, and it's getting this mixture up to a certain temperature. So it's going to be the temperature of one of the liquids. Get that one liquid to boil. It evaporates and collects in this tube, and it runs down, and then you collect it into a test tube. So what you end up with is the this flask here will contain one of the liquids, and this test tube down here will contain the separate liquid. So you've separated the two based on their boiling points. Crystallization is when you form a pure solid particle from a solution. Chromatography allows you to separate components of a mixture using chromatography paper. So they go different distances along that paper. So these are all different ways, just a few of the different ways that you can separate a mixture into its different parts.